Hello everybody, welcome back to our channel, Web Designs. Now today, this is going to be our last video of the LLM Engineering course. Today, we will go to chapter 5, which is fine-tuning GPT4o mini. It's time to get a dataset from Hugging Face and tailor an LLM to our needs. So now you may ask, what is fine-tuning? Fine-tuning is the process of taking a pre-trained model such as GPT's models, which are GPT4o, GPT4o mini, GPT4o, O1 Pro, and further training it on a specific dataset to make it more specialized in a particular task. Instead of training a model from scratch, fine-tuning allows for faster, more efficient adaptation while preserving the general knowledge during its initial training. So here we have our pre-trained LLM, which is trained on raw text data, right? So what we're going to do is take a custom knowledge that we are going to curate. We're going to give it to GPT4o and then we're going to get a fine-tuned version of it. So what is our LLM more specialized? What are we fine-tuning our LLM for? We're fine-tuning our LLM for guessing prices on its description. So it will be provided with a description and we will ask the price. It has to specify the price. And depending on if it's a good guess or a bad guess, we'll plot that in a graph. So this project will burn to sum of tokens that you have. So I want you to top up if you are low on the money for our API keys, or if you have it, good job, and let's get right into this video by going to the code. Alright, so now here we have our Jupyter notebook. So select your environment and activate your Conda environment. So I already have it activated. So now let me just hide this terminal. Alright, so now over here, what we're gonna do is first go with our some of our models. So this items.py, right? This is for the tokenization for our model. This loaders is where we load our data set, and then this testing.py is where we test the LLM to see how good it is. You don't need to go in that detail of these .py's as because that are not important. What are important are these two Jupyter notebooks which we are going to use to fine tune our LLM. So first, let's go with some imports. We have os random.env. So I think you should know all of these models. From Hugging Face, we are importing login so that we can log into Hugging Face. We're importing datasets, you know why. Then from items, which is our .py, we're importing our class. From loaders, item loader. From map.ly, we're importing plot, plt, for creating visualizations. We are importing our new library, collections, which provides tools for counting and handling default dictionary behavior. NumPy, you should know that. And pickle, used for serializing and deserializing Python objects. So let's load our environment variables, log into Hugging Face, and let's write that magical command that allows map.list plots to be displayed directly in Jupyter notebooks. Let's try loading a dataset called appliances. So now over here, let's take a look before that at our dataset in Hugging Face. So now here we are in Hugging Face, and our dataset is Amazon Reviews 2023. Alright, so now over here there's a bunch of categories over here, and appliances is a really small one, so it should take a little time. It should only take this little amount of time to download it. So let's try that. And what I recommend is first know what this dataset is about and learn a little bit about it before you use it. So now let's try loading that dataset in. And to run a code snippet, you just have to press shift and enter, or you can also just use this button over here. So now loading this dataset may take some time depending on your computer. My computer is a MacBook Pro, so this should take less time for me. Alright, so now it is done. So now let's look for an item. So let's look at the second item. How much does it cost to the nearest dollar? So here we have a door pivot block, compatible Kino, KitchenAid. Alright, so now I don't know all these technical words, but I think it's not worth that much. And if I look over here, it's worth $17, which is a lot. But I think if it's worth it, maybe if you're getting all of these. Alright, so now here, if you have this, then your dataset of appliances is loaded. But then I think you have to run it again, or you forgot to run it, or you don't have enough space. Alright, so now for this, you really need some storage, because this is gonna take 500 megabytes is what I think. So now here we're going to import all of these categories. And don't worry, it gets faster. So this is the heaviest one and this is the lightest one. But if you want, you can remove some things, but then the performance will drastically decrease, okay? So now let's load our datasets. So now go take a coffee break, as because these are very big datasets. And we put the datasets first, the biggest datasets first, so then it will get faster and faster progressively. So now here it is loading, and it would take a lot more, it will be more faster than for you, as because I have already run this and it's stored in my cache. So now I'll be back once the downloading process is done. Alright, so now it's done for me. It took 20 minutes 49.9 seconds, and it may take long for you, as because just as I said, it's stored in my cache. That's why it took way faster than usual. So now let's look at the grand total amount of items. And if you look, there's 2811408 items, which is a lot. Let's plot the distribution of token counts. And if you look over here, we get a bar over here. Then the highest is 179. And the average is 176.7 tokens. So now let's plot the distribution of prices. And if you look over here, it is mostly on the cheaper side rather than the expensive side, as because even if you go to like a convenience store, you find mostly cheap items in there rather than like very expensive items that are over $100. So now if you look over here, after the 200 mark, there is less and less and less in items until we get to the 1000 mark, where there are no more above. Alright, so now let's look at the chart where we get all the amount of items each of these categories contributed. So now here we have automotive with 900k, and then we have tools and home improvement with 500k, and then we have electronics with 400k, we have toys and games with 300k, we have office products with 240k, then we have cell phone and accessories with 238k, and then over here we have the smallest ones, which are appliances with 28,625, and the musical instruments with 66,829. So now the objective is craft a dataset with more balanced in terms of prices, less heavily skewed to cheap items, with an average that is higher than $60. So let's try to balance out the categories. Fewer automotive items should do the trick, as because this is exceeding over 1 million. Let's create a dictionary with a key of each price from 1 to 999, and then in value put a list of items with the price to the nearest round number. So now let's create a dataset called sample, which tries to more evenly take the range of prices and gives more weight to items from categories other than automotive. Set the random seed for reproducibility. So here we set the random seed so that when I run it, you can get the same result again. So here I got the result of 408,625 samples items in the sample. So now let's plot the prices in the sample we generated. And if you look over here, it's still skewed to the cheaper items. But if you look over here, we have more expensive ones over here too. So you may ask, why should we also have the expensive ones? As because for our LLM, if you only have cheap items, it's going to only guess the cheap items. So that's why we're going to also skew the cheap items so that the expensive ones could stand out more. Okay, we did well in terms of raising the average price and having smoothish population of prices. So now let's see the categories. So now if you look over here, automotive is still in the lead, and we have tools and improvement not far behind. Then we have electronics, and then the other ones are skewed more down a little bit, and by a little bit a lot. So as because if you look at appliances, there are only 4,000, musical instruments 7,000, cell phones and accessories with 8,000. So now if you look at cell phone and accessories in our previous bar chart, it's 238k, but now here it has drastically fallen to 8,764. But automotive is still in the lead, but improved somewhat. For another perspective, let's look at a pie chart. So now if you look over here, we have electronics, we have tools and home improvement, we have office products, we have automotive which has 35%, followed by tools and home improvement, electronics, we have office products with 6%, then we have toys and games with 8%, we have musical instruments with 4%, cell phone accessory with 2%, and appliances which only has 1%, as because it's a very small category. Alright, so now the dataset is curated. So let's see how does the price vary with character count of the prompt. So let's plot a scatter plot. So now if you look over here, there's a faint line over here. So if you look, there's a line over here, there's a line over here, there's a line over here. So there is some resemblance and patterns over here. So now over here, let's report a sample 3980. This is a random sample. Alright, so now over here, this is a mono RS causeway lowering kit, and the price is this much. So now here we're actually getting expensive items rather than cheap affordable items. So now finally, what we're gonna do is only take the first 100k items, and then we're gonna split it so that 2000 is left for our test dataset. So now here we have divided the training dataset of 400 items and test of 2000 items. So now let's place one of the training items, which is the first one. So this is a Delphi FG0166 fuel pump module at a price of 227.00. Let's look at the test one. How much does this cost in the nearest dollar? It's an AC compressor repair kit for fraud something. And then the price is not there. Do you know why? As because this is a test prompt, we don't need to give it the price, as because it's the answer our question. So now let's plot the first 250 test points. So now if you look over here, this is the first 250 test points, and it's still skewed to over in the cheap side. But if you look over here, there's also some expensive items ranging from $200 to around to $1,000. Finally, if you want, you can upload this dataset. So you can create a dataset from the list, and then over here you can uncomment these lines. So you put your HF user, then you have to give the dataset name, if it's private or not. So now once you have done that, so now over here you don't need to do this, but if you want, it's really helpful. And then you can create a train.pkl and test.pkl over here. This pickle file over here, train pickle, is around 500 megabytes, and test is, I think, somewhere around like 200 kilobytes. I don't know, but I think it's somewhere at that price. Alright, so now let's get into fine-tuning our model. So now over here we're gonna import OSRE math JSON random, then also .env Hugging Face so that we can log in our items. We have matplotlib numpy pickle so that we can load our dataset. We have collections, and over here we have OpenAI. I'm gonna leave you a homework for our last video, which is I want you to use Anthropic's API integration, such as the Claude models. So here let's import, and we're also going to import a tester model so that we can test if our model is good or not. So let's import tester also. Let's get our API keys. Let's log into Hugging Face. OpenAI equals OpenAI. Matplotlib inline. And then so that we avoid curating all our data over and over again, let's load in our pickle files. And over here you may wonder why am I calling it pickle files, as because that sounds good to me. But over here you should say it's .pkl files. But the library is named pickle, so why can't I call it pickle? So now over here, let's prepare our data for fine-tuning in JSNL. So you may ask, what is JSNL? And you may only know JSON. JSONL means is JSON live. It's a format we use to upload our data to OpenAI so that we can fine-tune it. So first, let's work on a good prompt for our frontier model. Notice that I'm removing to the nearest dollar over here. But when we train our models, we need to make the problem as easy as possible. But a frontier model needs no such simplification. Alright, so now when we run that, let's look at the messages for train 01. So here's role system. You estimate prices of items, reply only with price, no explanation. And then over here, content, how much does this cost? And we have over here definitely fuel pump, which brings 80 years of OHE in heritage. So and then the price is this. So this is for our training data. So now let's make them into JSON lines to convert the items into a list of JSON objects, a JSON string. Each row represents a message in the form messages. Then we have role, system, content, you estimate prices, blah blah blah. So now we are going to only make the JSON line of the first 3 elements. So now if we look over here, this is the JSON line of a Delphini fuel pump, a power stop rear Z33, and a 36 gas cooktop with 5 steel burners. So let's look at their prices. Over here, our Delphini we know is 226.59. Over here, 506.98, and $405. So over here, look, if we're having 9.5 or 9.8, but once we give it, it will already be converted into 00 to the nearest whole number. So now let's convert our entire items to write them to a file of JSON. So now say write JSON fine tune underscore train, which is our name, and then over here we're providing our JSON file, which is our name, so that we can pass into a function. Wait, oh, I forgot to run this over here. So OpenAI recommends fine tuning with populations of 50 to 100 examples, but examples are very small. I'm suggesting we go with 200 examples or 1 epoch. So now over here we have fine tune train, which is only 200, and fine tune validation, which is 200 to 250. Alright, so now let's run this, and also let's run this. And now if you notice over here, we have over here our JSON lines. So we have 200 over here, this is our train, and then we have, I think, which is 50 over here, yep, which is our testing data. So now over here, we open the fine-tuning training file in binary mode. That's what we are writing RB over here, and upload it to OpenAI for fine-tuning processes. So now let's look at our train file. So over here, if you look, we have this entire thing, which is a file object. So now let's do that for the validation file also. And now let's move on to step 2. So now over here, you need to know something called weights and biases, which is a beautiful free platform for monitoring training runs. Weights and biases is integrated with OpenAI for fine-tuning. So here you have to first set up the free weights and biases account, and once you're done, come back to this video. And now let's allow fine-tuning. So we have weights and biases integration. Then we are accessing the ID attribute of the train file. Then we are creating a fine-tune job with OpenAI's API. So here this is our fine-tuning job. Then we're going to list the fine-tuning jobs of a result of 1 only. So now we get the sync cursor page. So now we'll get the job ID of the most recent fine-tuning job, and then we'll try printing it. So our most recent fine-tuning job is this. We retrieve details of a specific fine-tuning job by its ID. Then we'll receive the events of a specific fine-tuning job. Alright, so now let's test our fine-tuning model. So we'll say fine-tune model equals OpenAI fine-tuning.jobs.retrieve job ID.fine-tune model. So now we'll print the fine-tune model. So now let's try printing it. So here, if it says run, don't worry. That's because let's run this. And then it still says status of validating files. So here, come back to this once it says succeeded. So it's still saying validating files for me. So I'll be back once it says succeeded. Alrighty, so now I'm done. So what we gotta do is copy this job ID over here. So let me copy that. I'm gonna paste this over here. And then now when we press shift enter, it was the model name. So we're gonna copy this. I'm gonna paste it in the fine-tune model variable. And we'll just press shift and return over here. And then we'll give it the prompt again. And let's try the test 1 over here. So now if you look over here our price is none. It only has $1. And we have the content over here also, which is our description. So now over here we're going to create a utility function that extracts the price from a string. So now let's press shift enter. Then we'll get the price so that we can try it. It'll give us 99.99. So now the function to call GPT4o mini. And then over here I'm just going to press shift enter. So that over here you can just test it really quick. And over here it gave us the result. So over here the test price for the first element was this, and it gave me this. So now over here, let me just look at the test prompt again. And over here, the moment we have been waiting for. So now over here, this, when we press shift enter, will test ChatGPT And over here it's getting some good guesses, that's what the green means, and some mid-range guesses, so that's what the yellow means, and the red means it's a very horrible guess. So if you look over here, so the guess was 349.9, and then over here the actual truth was $635, so the error was this much, so that's why you got it very bad. So now here we are seeing some reds and also some blues. So now over here the output will be truncated, as because Jupyter Notebook cannot display the amount of output there. So now I'll get back to you once it's run. Alright, so now we are at 200 guesses. So now over here we'll guess until 250. So over here, if you look, it is doing good, but then there are also some very bad guesses. But don't be fooled by that. Alright, so remember the homework I gave you? That's it. That's right. I want you to test Claude and see if it's any better than GPT4o mini. And over here, if you want, you can also try GPT4o, which will maybe do better. So now we are at the 250 guess mark. And if you look, we have a lot of greens, which is good. We have some yellows, and we have minimal amount of reds over at this side, but a lot of reds over at this side. So the y-axis over here is the model estimate, and then the x-axis is the ground truth. So here we have a straight line which has a gradient y, which has a line formula y equals x. And over here the red represents ChatGPT's bad guesses, the yellows represent ChatGPT's good guesses, and the yellows represent ChatGPT's mid guesses. The greens represent ChatGPT's best guesses. So here GPT fine-tuned error is 99.88. The RMSLE equals 0.8, and the hit equals 42%. So guess good 42% of the times. So that's it for this course. If you want a mobile React Native app, a React website, or a LLM from us, just please consult to us. We'll be happy to help you. So I hope you have a nice day, and this is Ishang signing off.